Welcome to a deep dive into business analytics.
Yeah, it seems like you've been taking some pretty interesting notes from a course called Introduction to Business
I
Analytics.
have,
And
yeah.
today we're going to be looking specifically at Chapter 3, Analyze the Data.
Okay, cool. So analyze the data. And the presenter of this course is Lisette Lawrence Ed.D. with degrees in computer science analytics and even learning analytics.
That's right. Yeah, she's got quite a background there.
Yeah, pretty impressive.
hmm
So let's dive into this chapter 3 and see what we can uncover. The first thing that kind of jumps out at me is this distinction between populations and samples.
Right.
Can you unpack that a bit?
Absolutely. So it really comes down to practicality. So if you imagine you're a restaurant owner and you want to know how many restaurants in the U.S. are closed on Sundays,
Okay,
you would ideally survey every single restaurant in the country.
right. That's a lot.
That would be your population.
Yeah, that'd be a huge undertaking.
hmm Exactly. So instead of trying to study that entire population, which is often too time-consuming or expensive, we rely on samples. And a sample is like a snapshot. It's a smaller, carefully selected group that represents that larger population.
Okay. And the idea is that by analyzing the sample, you can then make inferences about the whole population. That's where inferential statistics comes in,
You got it.
right?
It's like detective work. You're using the clues from the sample to draw conclusions about the bigger picture.
Okay.
So for example, if your sample showed that 20% of restaurants are closed on Sundays, you can infer that a similar percentage applies to the entire U.S. restaurant population.
That makes sense.
But here's the catch.
Okay.
The accuracy of your inference really hinges on how well your sample represents the population.
Oh, yeah, of course. If your sample is biased, your conclusions aren't going to be very reliable.
Exactly. And
Mhm.
that's where understanding different sampling methods and the potential for bias becomes really important. In your notes, I see you've highlighted different sampling methods like simple random sampling and stratified random sampling.
Right.
Each method has its strengths and weaknesses depending on the type of data and the research question.
And avoiding bias is key.
Yeah.
Whether it's selection bias where your sample isn't truly representative, or confirmation bias where you might unintentionally interpret data to fit your preconceived notions.
Right.
These biases can lead to inaccurate conclusions and ultimately bad business decisions.
Absolutely. And that's why it's so important to be aware of these biases and to use rigorous sampling methods to minimize their impact.
Okay.
It's like building a house on a solid foundation. If your data is flawed from the start, your analysis won't hold up.
Makes sense. So, okay, so we've got our sample and we're mindful of potential biases. What's next?
Now we need to understand the data itself.
Okay.
In your notes, you've got a section on different types of data, continuous and discrete.
Okay.
Can you give me an example of each?
Sure. Continuous data can take on any value within a range, like a person's height or the temperature outside. It can be measured in fractions or decimals. Discrete data, on the other hand, can only take on specific whole number values. So think the number of customers who visit a store each day. You can't have half a customer.
Exactly. And understanding these distinctions is really crucial because it influences how we analyze the data.
Okay.
Different statistical techniques are appropriate for different types of data. And in your notes, I see you've also got information on levels of measurement, nominal, ordinal, interval, and ratio.
Right?
It's like having different tools in your toolbox. You wouldn't use a hammer to tighten a screw, right?
Right. The tool you choose depends on the job at hand.
And the same applies to data analysis.
Okay.
Understanding these levels of measurement helps you select the appropriate statistical techniques to get the most accurate and insightful results.
Now, speaking of insightful results, I'm intrigued by this concept of probability distributions.
Okay.
It sounds a bit intimidating. Can you break it down for me?
It's simpler than it sounds.
Okay.
Think of a probability distribution as a visual representation of how likely different outcomes are. You've probably heard of the bell curve
Sure.
or the normal distribution. It's one of the most common and important probability distributions in statistics.
Okay, so if we're talking about something like the height of adults in a certain city, we might see a bell curve where most people are clustered around the average height with fewer people at the extremes of very tall or very short.
Precisely.
Okay.
The normal distribution is a powerful tool because it allows us to understand how data is typically spread out, and it forms the basis for many of the statistical tests that we use to draw conclusions from data.
So we've talked about populations versus samples descriptive versus inferential statistics, different types of data and levels of measurement and probability distributions.
Mm-hmm.
That's a lot to take in,
It is.
but I have a feeling we're just getting started, right?
Yeah, right about that. There's a lot more to explore in the world of business analytics, and the next chapter in your course looks at measures of central tendency and dispersion. We'll use these measures to summarize and describe data revealing important patterns and insights that can help drive smarter business decisions.
Okay, so let's delve into those measures of central tendency and dispersion.
Okay,
They sound like something you'd find in a dusty statistics textbook.
right.
but I bet they have some really practical applications.
Absolutely. Think of them as tools to kind of get a quick snapshot of your data.
Okay.
Measures of central tendency tell you where the center of your data lies, what's typical.
Okay.
So we've got the mean, which is the average, the
Right.
median, which is the middle value when your data is ordered, and the mode, which is the most frequent value.
So if we're analyzing like customer purchase amounts, the mean would tell us the average purchase, the median would give us the middle value of all the purchases, and the mode would show us the most common purchase amount.
Precisely. But understanding when to use each measure is key.
Okay.
For instance, if your data is skewed by a few extremely high or low values, like a data set of salaries where a few executives make millions, the median might be a better representation of the typical salary than the mean.
That makes sense. Yeah. You wouldn't want a couple of outliers to give you a distorted picture of the overall situation.
Yeah, exactly. Now, in addition to central tendency, we also have measures of dispersion, which tell us how spread out the data is.
Okay.
So we have the range, which is the difference between the highest and lowest values, variance, which measures how much the data points deviate from the mean, and standard deviation, which is the square root of the variance and is often easier to interpret.
So a small standard deviation would indicate that the data points are clustered closely around the mean,
Right.
while a large standard deviation suggests that the data is more spread out.
Exactly. And these measures of dispersion are crucial for understanding the variability in your data.
Okay.
For instance, if you're a marketing manager analyzing the performance of different ad campaigns, knowing the standard deviation of click-through rates can help you assess the consistency of each campaign's performance.
That's a great example. Yeah, it's not just about the average click-through rate, but also about how much the individual data points fluctuate around that average.
Precisely. Now, once you have a good grasp of your data using these descriptive statistics, you can start to dig deeper with inferential statistics.
Okay.
And that's where hypothesis testing comes into play.
I see we've got a lot of notes on hypothesis testing. It seems like a pretty central concept in business analytics.
It is. It's essentially a way to test an assumption or a claim about a population using data from a sample.
Okay.
So let's say you're a product manager testing a new website design.
Right.
Your hypothesis might be that the new design will lead to a higher conversion rate.
But we gather data on conversion rates before and after the design change, and then use hypothesis testing to see if the difference is statistically significant.
Exactly. We start by assuming there's no difference. That's our null hypothesis.
Okay.
And then we use statistical tests to see if the evidence is strong enough to reject that null hypothesis and support our alternative hypothesis,
Okay.
which is that the new design does lead to a higher conversion rate.
And that's where concepts like alpha and p-values come in, right?
Yes, alpha is the level of significance we set,
Okay.
which is basically the probability of making a type I error,
Okay.
rejecting the null hypothesis when it's actually true. A common alpha level is 0.05, meaning we're willing to accept a 5% chance of falsely concluding that the new design is better.
So it's like a trade-off between being cautious and potentially missing a real effect, or being more bold but increasing the risk of a false positive?
Precisely. And then we have the p-value,
Okay.
which is calculated from our data and tells us the probability of getting our observed results if the null hypothesis were true.
Okay.
If the p-value is less than our chosen alpha, we reject the null hypothesis and conclude that the new design is likely better.
It sounds like hypothesis testing is all about making decisions based on probabilities and weighing the risks of different types of errors.
That's a great way to put it. Now, you might be wondering which statistical tests are used in hypothesis testing.
Yeah.
Well, in your notes, you have a section on t-tests, ANOVA, and chi-square tests.
Okay.
Each of these tests is designed to answer specific types of questions about our data.
From what I understand, t-tests are used to compare the means of two groups,
Mm-hmm.
while ANOVA can be used to compare means across 3 or more groups.
That's right. For example, if you wanted to see if there's a significant difference in customer satisfaction scores between two different customer service approaches,
Okay.
you might use a t-test. But if you were comparing satisfaction scores across different age groups,
Okay.
you'd likely use ANOVA.
And chi-square tests are used for categorical data, right?
Yes.
Like if we wanted to see if there's a relationship between customer gender and product preference.
You got it. These tests are like specialized tools in a data analyst's toolkit.
Yeah.
And choosing the right tool depends on the type of data you have and the question you're trying to answer.
This deep dive into statistical concepts is really starting to paint a clearer picture of how data can be used to make informed decisions. But it's not just about the numbers themselves, is it? There's also the visual aspect. using charts and graphs to bring the data to life.
Absolutely. Data visualization is a crucial part of business analytics.
Okay.
It helps us identify patterns, trends, and outliers that might not be readily apparent just by looking at raw numbers. In your notes, I see you've got some information on tools like Excel, Power BI, and Tableau,
Right.
which are all fantastic for creating visually compelling and informative data representations.
I'm particularly intrigued by Tableau. I've heard it's incredibly powerful for creating interactive dashboards and exploring data in a very intuitive way.
It is. Tableau allows you to drag and drop data fields, create different chart types, and easily filter and drill down into your data. It's like having a digital playground for data exploration.
And that exploration can lead to some really valuable insights, right? Spotting trends, identifying areas for improvement, uncovering opportunities that might have otherwise gone unnoticed.
Precisely. And the best part is that these insights can be easily communicated to stakeholders through clear and compelling visualizations.
Right.
A well-designed chart or dashboard can tell a story that resonates with people and drives action.
This whole conversation about data visualization has really piqued my interest. It's like taking all those statistical concepts we've been discussing and turning them into something tangible and visually engaging.
It is, and it's a reminder that data analysis isn't just about crunching numbers in a spreadsheet.
Right.
It's about storytelling, uncovering insights, and using those insights to make a real difference in the business world.
We've covered so much in this deep dive, from understanding, different types of data to exploring these powerful statistical techniques and even, the art of data visualization. But something you mentioned earlier really stuck with me, this idea that while, numbers are essential, they only tell part of the story.
Right. That's a really important point. It's easy to get caught up in the qualitative side of business analytics, the charts, the graphs, the statistical significance. But we can't forget the human element. Behind every data point is a customer, a client, a person making a decision.
It's like that saying, statistics are human beings with the tears wiped off.
Yes.
We need to understand the why behind the numbers, right?
Exactly. That's where qualitative data comes in.
Okay.
It's about understanding the stories, the motivations, the context that gives meaning to those numbers.
Right.
Think about customer reviews, social media feedback, or even in-depth interviews. These provide a richness and depth that numbers alone can't capture.
So if we're seeing like a drop in sales for a particular product, the quantitative data might tell us that sales are down by 15%,
Right.
but qualitative data might reveal that, customers are finding a new competitor's product easier to use, or that a recent design change isn't resonating with their needs.
Precisely. Qualitative data helps us answer those why questions.
Okay.
It allows us to get into the minds of our customers and understand their experiences, perceptions, and needs. And when we combine these qualitative insights with our qualitative analysis, we get a much more holistic view of the situation.
Yeah, it's like putting together a puzzle. The numbers form, we outline the structure, but the qualitative data adds the color, the details that complete the picture.
That's a great analogy, and it highlights the importance of being well-versed in both quantitative and qualitative approaches. The most effective business analysts are those who can seamlessly blend these two worlds, using both data and human insights to drive better decisions.
And to wrap up, you touched upon two more statistical concepts, correlation and regression. Can you tell us a little bit about those?
Certainly, these techniques are all about understanding relationships between variables.
Okay.
So correlation measures how strongly two variables are related. For instance, you might find a positive correlation between website traffic and sales. As traffic increases, sales tend to go up as well.
But correlation doesn't necessarily mean causation, right? Just because two things are related doesn't mean one directly causes the other.
Exactly. There could be other factors at play. Now, regression analysis takes this a step further. It allows us to create a model that predicts the value of one variable based on the value of another.
Okay.
So we might build a regression model that predicts sales based on website traffic, advertising spend, and seasonality.
That sounds incredibly useful for like forecasting and making strategic decisions. For instance, a company could use a regression model to predict the impact of increasing their advertising budget,
Right.
or to estimate sales during different times of the year.
You got it. And the more data you have, the more accurate and powerful these models can become.
Wow. We've covered so much ground in this deep dive, from populations and samples to hypothesis testing, data visualization, and even delving into the human side of analytics. It's been quite a journey. I have to admit I was a bit intimidated by the topic of business analytics at first,
Sure.
but now I'm seeing it in a whole new light. It's not just about numbers and formulas. It's about using data to solve problems, uncover opportunities, and ultimately make better decisions.
I'm glad to hear that. And the best part is that this is just the beginning of your journey into the world of business analytics. As you continue learning and exploring, you'll discover even more powerful techniques and applications, and you'll find yourself using data to drive insights and impact in ways you never imagined.
Well, thanks so much for guiding me through this deep dive. It's been truly enlightening, and I feel much more confident and excited about diving deeper into the world of data and analytics.
It's been a pleasure. Remember, data is everywhere, and the ability to analyze it effectively is becoming increasingly valuable in every field. Keep exploring, keep asking questions, and never underestimate the power of data to unlock insights and drive positive change.